Okay, so continuing going over this, I'm sure these were pretty easy to fill in. If it had the square, it's a quadratic, meaning that it's going to make this shape here. If it has the absolute value symbols, you should have absolute value. Those are probably pretty easy to fill in, and quadratic here. From there, we're looking at the numbers. Remember, you do have that chart on the page before it that could help. This chart here has all the rules as well that can help. But here it has the -6 right there. That means to the right 6.
I didn't get that. Could you try again?
Yeah, I didn't understand that. Weird. Okay. To the right 6, and then +7 means up 7. And we'll get to graphing this in a second, but just the rules help us get started. So this is where we would graph our original point for the quadratic. And then absolute value here. We have a lot going on this one. We have a negative, which means a reflection. This coefficient of 2 means a stretch. This +3 means that it's going to the left 3, and -1 means down 1. So we have a reflection over the x-axis. The 2 is a stretch of 2. The reason why they call it a stretch and not a slope, on absolute value it's technically a slope, but when we talk about a linear function, we talk about slope, it's always like up 1 over. But with the absolute value, it's in both directions. So it's going to be a stretch in both directions. Or with a quadratic, it's not exactly slope. It's a stretch up or down. Who's that?
Why is it a reflection?
Because of the negative coefficient right there. If it has that negative coefficient, it's a reflection. Hi, guys. Do you guys have passes?
I tested.
Oh, they didn't give you a pass?
I think so.
That's lame. Okay. Well, jump right in there with us. Oh. Okay. Then we're looking at the +3 -1. The +3 in the brackets means to the left 3. And if I switch that up today, let me know because I keep getting it backwards. Left 3, and then the -1 is down 1.
Is this all for 17, or is this?
That's all for 17, yeah. And then 18 is a quadratic because that x is squared. We have a negative, so that's a reflection. So that means our quadratic is going to actually face down like this. And then the 4 is a stretch, so a stretch of 4. And then the -9 at the end means down 9.
Is reflection across the x-axis?
Correct. It like flips over.
How did you know that would be down 9 instead of right 9?
Because it's not in the parentheses, or in a parentheses at all. Like when we did to the right, it was inside of the parentheses. When it's not, that's K. So this is K. Okay. Next, while we're on this page, so we're going to go back and practice this on the page before it. There's like a whole bunch of graphs we're going to practice. But while we're on this page, we'll practice with these two. And if you're feeling confident and want to work ahead and stuff, that is totally fine. But I know it's probably 50-50. Some of you are ready to run with this, and some of you are probably still like, oh, I need somebody to hold my hand. So, number 11, just first looking at it, I have the x squared, so it's a quadratic. A quadratic looks like this. Now, as far as the transformation, looking at these numbers, it's a negative x squared, so that means it's a reflection over the x-axis. So instead of it pointing upwards like this, our quadratic's actually going to go down like this. And then the +3, that would mean up 3. Oh, it's blurry though. Why is it so blurry? There it goes. Okay, now next step is to start graphing. For the parent function for a quadratic, I'm doing this point in pencil. It's at 0, 0. Well, for this transformation, we have to go up 3 from that original. 1, 2, 3. So our point is actually going to be up there. And then our quadratic is going to like go down like this.
Don't you have to reflect it? So it is reflected negative.
What's that?
Shouldn't y be negative 3? Because you're
No.
wait, no.
No. I think you're overthinking it. Yeah, try not to overthink it because... Okay. Then from here, we need to get exact points or some exact points. We're going to plug in values for x and see what the output is when we solve it in the equation. I'm going to specifically choose numbers that are right around this one. So this one's at 0 on the x-axis, so I might choose 1 and maybe 2. So plugging that in, I get negative 1 squared plus 3. So negative 1 plus 3 is 2. And then for the next one, I get negative 4 plus 3, which is negative 1. And then 2, negative 1 will be right here.
Don't
Okay.
you have to square the negative one?
I did. Wait, where?
Or when you plug it in?
I didn't plug in negative 1. Wait. So wait, I plugged in 1. 1 squared was 1. And then it had a negative on the outside, so I brought that down. And then negative 1 plus 3 was 2.
Oh, okay.
Okay, and then I used those 2 points to graph this side. If I was to plug in the negative 1 and negative 2, I'd get the same numbers on the opposite side. And then I can just bring that down. Okay, so domain and range now. This would continue extending out ever so slightly forever and ever. So my domain is negative x to, or negative infinity to positive infinity. Whoa, focus. Okay, that's the x values. Range, my lowest y value, see how it goes down forever and ever. So my lowest y value is going to be negative infinity. And then my highest y value is right here at 1, 2, 3 with a closed bracket. What happens here is for only the quadratics, you really have to do this type of solving. For the absolute value, you can just use the coefficient, which is kind of like a slope, to graph it. You don't have to do all this solving. There is a chart here if you want to do the solving. You always could, but you don't really have to. So number 12 is an absolute value function. So we're looking for something like this. Now looking at the transformation, it has a negative coefficient, so that's going to be a reflection again. So instead of looking for this, we're actually looking, it's going to look like this. It's reflected downwards. And then the plus 2, that means up 2. So from 0, we go up 2. Then our slope here is 1, or negative 1. So we're going to go down 1 over 1 in both directions. And it looks like this. Our domain is going to go out forever and ever, so negative infinity to infinity. And our range, our lowest y value, is going down forever, so that'll be negative infinity. And our highest y value would be at 2 with a bracket. Yes?
So is it only for absolute values that you like kind of get the slope?
Correct.
And for quadratic?
Yeah, that's why it's called a slope, or a stretch, because it's not really a slope for all of them. And even here, I mean, the slope is, it's negative 1, positive 1, and here it's negative, negative. So it's not really, but it's down 1 over 1. Okay, then let's go back to the page before it, and that's where we're going to practice today.
Do you need more tissue boxes?
Oh yeah, I put one out.
There you go.
Yeah, you can take it to your desk if you think you're going to need it. Yes. Yes, you can. You feel comfortable with this?
Which bathroom do you guys use?
Which bathroom is the closest? 5A, that way. Okay, so today we're going to work through these problems. We have about 30 minutes and 10 problems, so we should be able to finish it in class and maybe start homework as well. Your homework for this assignment, there's only five questions. I cut it down to 5, so it shouldn't take you very long. And you're literally matching like this to the graphs, so it's pretty simple. Also, as far as Khan Academy, I also assigned Khan Academy for the week too. A lot of them are repeats, so it shouldn't be too challenging. If you did it last week, you should be able to just jump on there and get those done quickly as well. But for today, focusing on this. Tomorrow we actually have more practice on graphing. So it's not new material tomorrow, it's just reviewing piecewise functions and just graphing and transformations. So we get another day of practice. But for today, we're practicing this. Do you want me to continue walking through it step by step? Some of you, yes. Okay, you're welcome to work ahead if you know what you're doing. Just check back and make sure you got the right answers. Okay, I'm going to continue. Okay, this one is absolute value. So it's going to look like this. Here we have the plus 5, so that means to the right 5. And plus 2 would mean up 2. And that refers to the original point. So 1, 2, 3, 4, 5, up. Did I do it backwards again? I did. I was doing that all last class too. Dang it. It's so backwards to me. Okay. My brain will probably never be reprogrammed. Okay.
So why is it left 5?
Because that's the rule. It's like opposite. If it's plus 5, it's left 5. I know it's backwards. My brain struggles too. Okay. Left 5 up 2. Then there's no coefficient there, so the slope is just 1, so up 1 over 1. And up 1 over 1 in the other direction. And there we go. Domain would be negative infinity to infinity. And then range, our lowest y would be at negative 2. Or wait, positive 2, sorry. Yeah, good call. Positive 2 and to infinity and beyond.
So for absolute value, you don't actually have to fill the box in.
Right, because it'll, whatever that is, it's like the slope. So you go up 1 over 1.
It's only for quadratic form. Is that, sorry, is
For-
it just a normal 2? Or is it
Why is it negative?
for the range?
It's normal 2. Positive 2.
Oh, why is it 2 to infinity then? The range?
Because it goes up forever and ever for the y. Like,
Oh, so 2 is its lowest.
yep.
Miss Silva,
Yes.
why is it up to instead of down to for like when you're doing the transfer?
Because the rule, it makes sense for the y, but it doesn't make sense for x. So this is the original equation we're working with. The minus is actually part of the equation, so this is a positive h, but here it's plus, so it's just up. So for plus h, it's to the left h, and then for minus h, it's to the right. For plus k, it's up that many units, or minus k, it's down that many units. Yes.
Where did you get the 2 fall in the range?
The range, so the range is your y values. The lowest y value, so this being our y-axis, the lowest y value is at 2.
Should it be negative 2 or something?
No, because if it was down here, it would be negative 2.
Oh, okay.
Okay. Number 2. It's a quadratic. So it's going to look like this. The plus 5, that means to the right 5.
So is that a bracket next
Isn't it
to
to
2?
the left 5?
Did I do it back? Oh my gosh, but I'm visualizing the other way. I don't know what I'm doing. Like I'm, in my mind, I'm looking at it the other way and I'm writing. Don't know.
Wait a minute, I'm on the wrong questions.
What do you mean you're on the, oh, you're on the other page? I don't know where you are.
All of them.
Okay. So, left 5. So from 0, we go to left 5. 1, 2, 3, 4, 5.
Information is a little bit different.
What's that?
The one
Oh.
that I was on the second
Oh,
page.
got
I
it.
thought I was just reading it wrong.
Got it. Okay, so left 5. Now as far as plotting our other points, the only way to do it is to solve for numbers, so we're going to use this function table. I recommend choosing numbers that are right around this point as far as x, because this goes up really fast, so if you don't choose numbers that are right there, it won't fit on the graph. So when I'm looking for numbers, I'm looking for maybe, if this is at -5, then maybe -4, and maybe -2. So that way it'll fall right in this area. And then I'll plug this in, -4 plus 5 squared, which would be 1. And then -2 plus 5 squared, which would be 9. And then I can plot these points. And it goes up like this. And then on the other side, same thing, just plot them the same distance away.
Is that a 4? -2, 4? Or is that a 9?
I put -4, 1, -2, 9.
9.
And then domain, -infinity to infinity. Range, our lowest y is at 0. And then our highest y is infinity.
Is that a bracket in front of the 2 for the first one?
Yes, it is. Okay. Next one, absolute value. The coefficient is negative, so it's going to be reflection. So our thing's going to go down like this. Okay, so this is right 2. And up 4. So our origin for this, right 2, up 4, 1, 2, 3, 4. Right here. Our slope is just a -1, so it's going to go down 1 over 1. And then domain, -infinity to infinity and beyond. Range, our lowest y value will be -infinity. And our highest y is 4.
Why is it negative infinity?
The lowest y.
Why?
Because it would go down forever and never, like,
Oh.
yes, you can. Again, if you're feeling confident, work ahead. I'm trying not to work too slow too because I want to finish it before class as well. Okay, now this one, quadratic, which will look like this. To left, or I mean, +2 would mean to left 2. And -3 would be down 3. So to the left 2, 1, 2, 3. So there's my original point. And then I need to graph points. As far as the numbers I'm going to choose for x, I might choose -1 and how about 0?
Could you choose -3 too?
You could.
So,
Yes.
How do you know what the domain is?
It's all the x values. So for like number 3,
Yeah.
it's all the x values. So this will continue going off all the way this way, and this will continue going all the way this way. So therefore, it's -infinity to infinity.
Is it normally always like infinity?
It happened. Yeah, I haven't come across a situation with these that
Why is one negative and the other one isn't?
because -infinity would be all your negative values, and then positive infinity would be all your positive values.
Okay.
Then here, plugging it in. 1 squared root 1 minus 3, negative 2. And next, another quadratic, a stretch of 2, minus 3 would be right 3, and minus 4 would be down 4.
Starts basically like a slope, right?
What's that? This,
Stretches like,
but not for quadratic.
how do you write? How do you draw it?
So you'd have to plug in numbers.
Quadratics can be you.
Yeah.
Wait,
Like, how do you find your starting?
how do you do the stretching?
So the starting point is this. That's how you find it from 0.
3 down 4.
How do you find the stretch? It's the coefficient here.
Oh.
So that's how I find stretch, but it's not quite a slope for quadratics. You have to plug in numbers. So I'm going to plug in numbers that are around this. 1, 2, 3, like 4. Let's say 4, and maybe, yeah, I could do 2. I'm going to try to get all the points on this side because then I can just repeat them on the other side. So I'm going to do 5 as well. If it even fits, we'll see. 2, 4 minus 3 squared minus 4. So 2 squared would be 4. 4 times 2 is 8, minus 4 is 4. Ooh, my graph is really tiny. Okay, so it goes up like that. Then the other side, it'd be the same thing. Ish. Something like that. And then domain, even though it looks like it's going straight up, it is going out to the left and right ever so slightly. So our domain is negative infinity to infinity. And then range, our lowest y value is at 1, 2, 3, 4. And then it goes up forever and ever. Thanks. Next. Okay, I'm moving over to the next page. Are we okay with that?
Where
Oh.
does the stretch come in? Or do you just not?
What do you mean?
What do you do with the stretch?
It's affecting how, like, see how this is more spread out? With the 2, it's a vertical stretch, so it's going up steeper.
Does it actually affect like your slope or anything? Like,
Well, there isn't quite like exactly a slope with the
so, like how much you go off the
it does like climb faster straight up.
Okay.
Yes, you can. Okay. Next, number 6. Okay, 5 would be a stretch of 5. This is absolute value. So it's going to look like this. Plus 2 would be up 2 for the original point. Okay, so the original point would be up 2 from the origin. And then stretch of 5 for absolute value. Yes, it's going to be steeper up there, but we can use it as a slope. So we're going to go up 5 over 1. Like this. In both directions. So it's going to look like this. And then for domain, negative infinity to infinity. And the range, the lowest y would be at 2, and it goes up to infinity.
For the domain, why is it negative infinity?
Because it continues going out to the left forever and ever. Like,
And then it's positive because
for domain, so these would be all the negative values, and these would be all the positive values.
oh, okay. And it's going up.
What do you,
Like it's going straight up on both sides.
it's not completely straight, but as you can see, this one's a lot steeper than these. Remember, this had a slope of 1, and this had a stretch of 5, so it's going to be steeper. Next, quadratic. It's got the reflection, that negative coefficient, the -1 means the right one, and +4 means up 4. So this has to do with the original point, and this has to do with a line. So original point is right 1 up 4. For this, it's going to be going down because it does have that negative. Okay, so from here, we're going to have to plug in values. I'm going to use maybe 0 and how about -1? So then I'm going to plug these values into the equation. -2 squared would be +4. -4 plus 4 is 0. And then domain, -infinity to infinity. Range, your lowest y is going to be -infinity, and your highest one is at 1, 2, 3, 4. Then over here, absolute value, +1 means left 1, -3 is down 3. Then your slope is 1, so it's just up 1 over 1.